All right, guys, I'm going to try to make this video for you to help you review with the schedule being so off. This will allow you to watch and listen in your own time. Some things we need to be ready for on this final. One of the main things I want to see is anytime we have a polynomial, remember, anytime that it crosses the x-axis is a solution. So if I've got this polynomial right here, I see a crossing, crossing, crossing. Anytime we have a crossing that is on the x-axis, wherever these points may be, let's call this -1, 2, 3, and 4, 1, 2, and 3. Remember, these crossings represent solutions. So we have a solution at x equal to -1. We have a solution at x equal to -4. And we have a solution equal x equal to 3. Those are solutions. Those are real solutions. But remember that each of these solutions comes from a factor. This factor comes from the x equal to -4 comes from the factor x plus 4, the opposite of that. This comes from x plus 1, and this one comes from x minus 3. So we have a video, I have a video for this on Canvas. If you just look back at the calculator tips, it'll talk you through putting in your calculator and reading these different things. So keep that in mind. That's very important. You can also look up some stuff like the y-intercept. Wherever it crosses the y-intercept is a constant value for that function. Next thing we're going to talk about is the vertex. Anytime we are finding the highest or lowest point, remember we are using this and we're finding the vertex. Also in the calculator tips, look in that and you'll see how to find the maximum and the minimum. Remember, a couple of things here. We've got a parabola, let's just say it opens this way. Well, we have a parabola that does have a maximum and it does not have a minimum because it is not it's no end to where it's going down. Again, there's our y-intercept. That should be the constant value. So if it's going through the origin, there should not be a constant value. But a couple of things. Remember that this is the vertex. The vertex is an ordered pair. It is the xy ordered pair of the highest point. Again, look on Canvas, and I have the calculator tips on how to find the maximum and the minimum and the vertex. Also, part of the vertex is the axis of symmetry. There is a formula for the axis of symmetry, which is the opposite of b over 2a, and that will give you if it's written in standard form. But if it's not, we can always graph the thing and see where this is. So that is the x value of the vertex. Also, we'll be seeing some complex number stuff. Remember, on the complex numbers, they act just like variables. So if I have 2i plus 5i, that does equal 7i. So they do act like variables, except for when they get powers. Because remember, when we have I to a even power, but if I have I squared, remember that does equal -1. So keep that in mind as you're working through those. The complex numbers will add together, and obviously the traditional numbers. If I've got 5 and 3, that's going to make 8. So you will see complex numbers just like that. Next thing you'll see is solutions and trying to determine what type of a solution we're looking at. So if I have a quadratic equation, a couple of things I want to remind you of. A solution is a solution. If it crosses straight through, that is a single solution. If we get a weird movement in space just like that, that is the sign right here that we probably had an imaginary solution of some sort. So we'll be seeing eyes. And remember, eyes always travel in pairs, so there will be a plus or minus situation anytime you have this weird wiggle in space. That's going to be imaginary numbers. I also put a second thing here, which is a multiplicity. Remember, whenever it does one of the movements, it is a multiplicity. This one would be an even multiplicity because it has the bounce effect. but also remember that they can have that wiggle effect. So if we go down here and it wiggles at the x-axis, that is the sign of an odd multiplicity. So imaginary solutions, they look like this. They get this weird movement in space, and they always travel in pairs. Also remember, any irrational answer travels in pairs. So if you have a square root of 7, well, the mirror image of that would be plus and minus 7. So keep that in mind as well as you work. Another thing you'll see is domain restrictions. The domain restrictions are going to be things that we cannot do mathematically. Two key things we cannot do mathematically. We cannot divide by the number 0. So make sure that denominators do not become 0. So if I see this function and it's x minus 6, all I've got to do is take this denominator and make sure that it does not equal 6. So I add the 6 over. So that means there is a restriction on the domain. I cannot use the number 6. And the other thing we cannot do when this is an even radical, let's just say I'm going to stick with the same thing, x minus 6. Radicals, the number under the radicand, cannot be negative. So we need to make sure that it stays greater than or equal to 0. So the restrictions on this domain, when I add the 6 over, would be x values greater than 6. So remember those two things we cannot do. We cannot divide by 0, and we cannot take the square root of a negative number. We also are going to be asked to expand binomials. If I give you a binomial, let's just say 3x minus 4, and I ask you to expand it. Let's say we call it a third power. Remember, this is not distribution. I cannot just distribute a 3 into those things. This is not multiplication. What we have is write it 3 times. So this would be 3x minus 4 times 3x minus 4 times 3x minus 4. This one's a very meticulous, longer question, but it's going to take some time. Yours is not cubic, so don't worry. So this would be 9x squared. I'm going to just start this one but not finish it. And then this would be negative 12x. Then I would move to the negative 4 times 3 would be negative 12x. And negative 4 times this would be 16. I would get this result by putting together all of my like terms. That would be 9x squared minus 24x plus 16. Put the parentheses back. And then at this point, I need to distribute all of these to both of these. I don't care the method that you use for these. We don't care what the method is that you use for these. Just some of you did the delta math like box thing where you did this 3x minus 4 and then 9x squared minus 24x plus 16, and then you broke it up this way and then you added like terms. That's fine. I'm good with that. Some of you did the stacking where we did the multiplication and we stagger them like this and then you combine like terms. That's fine as well. Here's one thing I definitely want to emphasize to you, and I hope if you catch anything you're listening. This is a calculator tip as well. Checking your answer. If I get y1 and type this in my calculator, the original question, and then I type the result in my y2, their tables should match identically. There is nothing stopping you from putting the question and the multiple choice answers straight into your calculator and seeing which ones have matching tables. If they have matching tables, it is the correct answer. And even if you have a question that says select all that apply, well, just make sure you plug in all 4 and see anything that has an exact table is a correct answer. Please do this on your exam. All right, this will save you some time if you just go straight to it. Another thing we're going to see the function notations. When we have something of this regard, when I have an f of x function and a g of x function, and then we're going to be asked to put f of x minus g of x. And remember, this is just saying to take the function f of x and subtract away the function g of x. Only thing I would advise on this is to make sure, especially on subtraction, you are going to be distributing a negative number. So if I say 2x plus 6, just for sake, and 3 plus 5, well, this is going to be 2x plus 6 minus parentheses negative 3x plus 5. Because there's a big difference, because this requires a distribution of the negative sign, which is going to change everything, of course. This becomes 2x plus 6 plus 3x minus 5. Like terms, so this one would be, whoops, that. You'll see some piecewise functions on there as well. Evaluating piecewise functions. Just remember, if this is and you're going to have to create some piecewise functions as well. But let's just say I've got a piecewise function that goes from here to there. Got the line. This is negative 1, 2, and 3. Well, this is a piecewise function that picks up at x values greater than 3. Let's say that the next one picks back up right here. I'll call it a parabola, just like this. And if I ask you the f of 4, remember, the f of 4 means when the x is 4. Well, if I'm looking at this graph that I've got here, here's the x-axis. X is equal to 4 right here. All I've got to do is follow this up until I see an intersection. So this intersection, wherever that value might be, let's just 1, 2, 3, 4. So this one would be the value for 4. So be prepared for those, and be prepared to construct a piecewise function as well. Multiplying polynomials. Multiplying polynomials will be another thing that you could see. So if I'm multiplying a polynomial, again, choose a method that works. If I have 3x plus 2 times x squared minus 6x plus 5. Again, choose the method that you like. 3x cubed minus 18x squared plus 15x. Then I move to the 2 next. 2 times this is 2x squared minus 12x. Forgot my x on the 15. And 2 times this is 10. So the solution to this particular question would be 3x cubed minus 16x squared plus 3x plus 10. Now let me re-emphasize this. y1, y2, and the tables will match identically. I cannot emphasize the importance of checking your answers or even getting your answers, because this is a multiple choice test. So the answer is there. It's not like you're searching for it. You just have to locate it. Increasing and decreasing is another phrase you're going to say. What intervals is it increasing or decreasing? So if I throw a parabola in right here, remember it increases between the peaks and valleys. So right here is a peak. So we're increasing on this interval right here. We're increasing up to this point. Let's call this point -2, or -2. So we're increasing for x values less than or equal to -2. Well, just less than, not equal to, sorry. And then we have a decreasing happening. We have a decreasing happening from -2 to, let's just call this +2. So we are decreasing. We are decreasing from values -2 to 2. And then we finish with increasing for x values greater than 2. Also remember the end behavior on this. This one is reaching to -infinity. This one's reaching to +infinity. So as x goes left, y also goes to -infinity. As x goes to +infinity, y goes to +infinity. So that would be our end behaviors. Remember solving. Solving is just solving. Get x by itself and go for it. Systems of equations. Solving systems of equations. Remember the general idea of solving a system of equation. If I've got two lines, regardless of what their shape is, call it a straight line and a parabola, the most basic of ideas of a system is anytime they cross one another is a solution to a system. Don't overcomplicate that. That's exactly what it is. You're also going to see matrices and pulling information out of matrices. But remember, we need to put these in order. X, Y, Z, and then constant value. If we have a 3 by matrix, if we have a 3 by, we're going to have 3 terms here. So on this particular one, we're going to have my values here. So if I have 2, 3, 5, 5, and 5 and 8, 1, 2, 3, 4, and then just 5, -2, 6, and 12, -12. Remember, that's how we stack those. So this line right here would be 2x plus 3y plus 5z equals 8. You'd have to put those together and pull those apart. Next thing we'll see is systems of inequalities. So if I've got a parabola that looks like this, and my shaded region is right here, remember the shaded region indicates all solutions to that system. So if I'm asked to find a solution, just pick any point that falls inside of this value. You know, if I were to back up -1, 2, 3, 4, 5, and up 2, 1, 2, that would be a solution to the system. Remember the most basic of ideas for domain and range. The domain is how far left and right the function moves. So if I've got a function that looks like this, the domain would be all real numbers, and in this case the range would be all real numbers because there is no limit to the left or right movement I'm seeing here, and there's no limit to the up or down movement. So what I might see a function that looks like this. Well, this one has a restriction on the domain and the range because the function doesn't go any further back than -4. So my domain would be x values greater than or equal to -4. That would be my domain. And my range goes down to, let's call this -3. So it only hits values that are greater than or equal to -3. So that's our domain and range. Just more topics here. Transformations, remember your basic idea on a transformation. Anything that happens inside of the parentheses is a left to right movement. And anything that happens outside is an up or down. You will see those. And then an A in front is a stretch or compression. This is true whether it's a quadratic like I just drew, or an absolute value, or if it's cubic even, which it will not be cubic. We haven't talked about those yet, but if it were, it would be the same thing. Remember, this is left to right movement, horizontal. This is up or down movement, that's vertical. And then these are your stretches, vertical stretch. You'll also need to know your SOFAs. Remember this acronym for SOFAs. Square the first, opposite sign, first, times last, or second, however you want to call it, and then always add. Always add. So if I had a cubic function that I'm trying to factor, like this one, all the terms have to have a perfect root. If they do, we put the perfect roots right here. And then the last part is the sophist. Square the first, that's this. Opposite sign, so it should be addition. First times last, well, 4 times x is 4x. Always addition, and then, sorry, forgot this, square the last. Square the last. So that would be 16. Sophist will be on there. Dividing polynomials. Remember to use either synthetic division or polynomial long division. So if I'm dividing by this, remember that goes there. Whatever the number is I'm dividing from, let's just call it plus x minus 15. Remember, we only put the leading coefficients, 1, 1, and negative 15. So this would be 1, negative 2 times that goes here. That gives me negative 1. So this one will have a remainder. Remember this, if it has a remainder, that means that it is not a factor to the function. This one has a remainder of 13, which means x plus 2 is not a factor of x squared plus 15. X squared plus x minus 15, excuse me. And then the last thing you're going to see is the last topic we talked about, which is your sequences. Your sequences. Remember, we have arithmetic and geometric. Remember, arithmetic is a common difference. So we see a increasing or decreasing change, adding or subtracting. Geometric is a ratio, multiplication, or division. But remember, it's not technically division. We call it multiplication by a fraction. Our formula for arithmetic is the first term, a sub 1, plus the common difference times n minus 1. And the formula for geometric is the first term times the ratio to the n minus 1 power. And from there, we just plug in our values and see. Let me encourage everybody to look at those videos that I've created for your calculator. It's going to be very helpful to you, especially on the polynomial stuff. But look those over.